I'm going to give one last example of p-value that, if you remember, back in, I think, chapter 4, I gave an example like this as an introduction of why we discuss probability. And I want to go back to that example because this is another example of how p-value works. You and your friend are playing a coin tossing game. So let's say you choose heads, and if you toss it, and if heads is the first to come up 10 times, you win. If the tails is first to come up 10 times, then you lose. So your friend wins. You toss the coin 12 times, and the coin comes up. As there would be tails, I guess. It would come up tails 10 out of those 12 times. And so if you want to figure out if the coin is loaded or not, well, what are we trying to figure out? We're trying to figure out the following. If the coin is fair, what is the probability of getting at least 10 heads? So let's set this up in terms, and that's our p-value. This is a p-value. So let's see. I'm going to say, null hypotheses can be written out in words. I'm going to say the coin is fair. And I'm going to alternately hypothesize that the coin isn't fair. It's loaded somehow. This thing will not let me make straight lines for whatever reason. Okay. So I'm going to find the probability of getting at least 10 heads. Well, how can we do that? Well, we're not going to use z-tables in this. If you recall, back to chapter 5, what we have here is a binomial probability. We have n equals 12. You flip the coin 12 times. What is p for the binomial probability? Well, we're going to assume it's 0.5. We're going to assume, again, by default, we're going to assume the coin is fair. That's why I'm saying p equals 0.5. So assuming, this is the assumption that the coin is fair. It has a 50% chance of getting either heads or tails on any given toss. So what I really want to find is the probability that x has, well, a value at least as extreme as 10. So I'm going to say x is greater than or equal to 10. So I have to find those binomial probabilities, and that will be my p-value. So I got to find out probability that x equals 10. Well, that is our binomial probability. We have 12, choose 10, 0.5, well, 10 successes, so to speak. Although it's not really a success because it means you lost, but again, we know that success in statistics is not always the same as success in general. Okay, so essentially what we have, let's figure out 12, if we can calculate 12 choose 10, it's going to be 12 times 11, and then 10 through 1, 10 through 1 on the bottom, and what's going to be left of is 2. So this is going to be 6 times 11, it's going to be 66 times 0.5 to the 10th times 0.5 to the 2 is just going to be 0.5 to the 12. 0.0161. Okay. Probability of getting 11 tails. Well, that's going to be 12 choose 11, and it's going to be 0.5, 11, 0.5 to the 1, and 12 choose 11 is going to be 12, and 0.5 to the 12, and that's going to be 0.0029. And now finally, the probability of all tails. Well, okay. We have 12 choose 12, 0.5, 12, 0.50, which is just going to be 1. And that's going to just be the same thing as 0.5 to the 12th power. It's going to be very tiny, and 0.0002. More or less. Okay, so again, we know that the probability, because binomial, the probability of 10, 11, and 12, well, these are disjoint probabilities. I can't get 10 heads and 11 heads, or 10 heads and 12 heads. So 10 is going to be the probability of x equals 10 plus probability of x equals 11 plus probability that x equals 12. And so I'm going to add up those probabilities, 0.0161, 0.0029, and 0.0002. And I get 0.0192. Okay, so what does the 0.0192 mean? That is our p-value. It means that if we flip this coin 12 times, this is the probability of getting at least 10 tails out of those 12. Now, we didn't choose an alpha value here, but 0.0192 is fairly strong evidence against the null hypothesis. If we were, for example, using the standard alpha 0.05, we would reject the null hypothesis. So there's fairly strong evidence to show that to reject and say that the coin probably is not fair. So there's another use of p-value, that another example that shows you the use and meaning of p-values.